Alright, here's another statics review problem for the final. Okay, again it's statics, and so we consider this truss. We've already talked about, we use the symmetry of the truss and treat the truss as just some structure that forces are applied to. Okay, so we can do the free body diagram, and so a free body diagram would look like this. This time the roller is on the point E, and so we only have a force E moving up. There's no horizontal component because of the roller. For point C, we have a CY and a CX because that's a pin, and so with a pin there's two directions of forces. Okay, we don't actually need these intermediate truss members, and so let's just leave them out. What we do know also is this is the angle alpha, and we have a 400 Newton force applied where here's alpha, here's another alpha. Okay, and we know the height of this structure is 8. Okay, this is 12, this is 12, and from symmetry, I mean it's not looking like it in this picture, but from symmetry this is 6 and this is 6. Okay, remember it's the same dimensions as the previous problem. Okay, so with that we know we can calculate alpha. Alpha is going to be the arc tangent of 8/6. Okay, but what we need to do is we need to resolve the force, the 400 Newton force, into components. Okay, so I'm thinking if I had this angle theta, let me change colors so you can see it better. If I had this angle theta, I could resolve the 400 Newton force into an x component and a y component. Alright, so if I use a little geometry, extend this line out, this theta, from what we know about geometry, is the same as the theta we're looking for. And what we know is if we add all these angles up to make a straight line, we get 180 degrees. Okay, so we can find theta. 180 is equal to theta plus 2 alpha. Alright, where alpha is this arctangent. Alright, so from there we can find theta. Okay, so the rest of this, let me delete these all the way. So for the rest of this, I'm going to write sum of forces in the x direction equals 0. Alright, and so I see this 400 Newton force, but what is the component that's acting in the x direction? Well, you take the cosine of theta and you find the x component of the 400 Newton force. So 400 cosine theta. Alright, that's moving up. Then I forgot to put it in the free body diagram. There's also this 500 Newton force. Alright, so plus 500. Okay, then we have, I'm sorry, in the x direction. That's not in the x direction, that's in the y direction. Okay, then in the x direction we also have minus cx. Because cx is moving back to the left, minus cx is equal to 0. So cx is 400 cosine theta. So if you calculate theta, plug that into your calculator, I get cx to be 112. Okay, so there's cx. Alright, next we want to do sum of forces in the y direction moving up equals 0. So I look at this and I have to resolve this 400 Newton force. I know that would be 400 times the sine of theta to get the vertical direction of that force. Okay. Then we also have the 500 Newton force moving up. We have E moving up, and we have CY moving up. So that's the equations. Set that equal to 0. Okay, but there's more than one unknown in here, so we're going to need another equation. So we're going to use sum of moments, counterclockwise being positive, is equal to 0. Okay, so from there we look at the moments. We can choose a point. Let's choose the point C. Okay, so we're going to use C, and we need to know what is the moment generated by the 400 Newton force acting at the end of the truss. Okay, so let me just sketch a picture down here so it's clean. All right, we know this is 24 meters long. We have a force acting at theta around point C. All right, so what we need is the component of the force perpendicular to the length 24 meter. And so that would be looking like this, which is the y component of the 400 Newton force. All right, so this would be 400 times the sine theta. All right. All right, so that takes care of that particular moment. I'm going to erase that and just write down the answer. So what we have is 400 sine theta times 24. And then that creates, you can tell from that direction that that would be clockwise, so this needs a minus sign. Okay, next we have this 500 Newton force acting at the middle of the truss. Okay, so the moment arm there, let me change the color. Let's go with green. Okay, the moment arm there is the perpendicular length to the force. So the first force is acting vertically, you need the horizontal length. All right, so that would be 12 times 500, and this would force this to rotate in a clockwise direction. So we need plus 12 times 500. I'm sorry, it's minus because it's clockwise. Okay, and then finally we have the component E. Remember, we're drawing moments around the point C. Okay, so to find this, there's a couple ways you can look at this, but I extend this up. All right, and so E is acting at this point perpendicular to C. This distance would be 6 from the symmetry of the truss. All right, and this would cause this to go clockwise. So this would be minus 6 times EY equals 0. Okay, so those are the equations that you need, and when you solve, you get EY, the way we referenced it, EY is going to be minus 2,536 newtons, and I reference this coming up, which is the same thing as the positive 2,536 newtons going down. All right, so that's EY. All right, from there, you know EY, that's something you can substitute in for E. And so from there you can solve CY. Okay, and so I'll leave that up to you. What I get on that is 1,652 newtons acting in the positive up direction. Okay, again, the statics problem is a little harder because there was some trig involved in resolving a force component into x and y directions. But the basic idea is the same. Sum of forces in the x direction equals 0, sum of forces in the y direction equals 0, sum of moments around any point is 0. Use those to write the equations, solve for what you need.